You have to do this now.
What? I don't have that section finished, I think. But good news, I got Oracle.
Okay, everybody, if everyone's ready, what we'll do? Everyone ready? So the plan for this morning is we will run over the stuff that we go over the stuff that we did last week, which is all about inheritance, polymorphism, and the list, array list. And we'll finish off the thing we were working on Friday. So you guys will be doing a lot of coding in this class, hopefully, and not too much talking for me. And then we'll do the bullet lab from, what was it, last week? Yeah, we'll finish off the bullet lab. And then the next sort of, the last sort of topic on this is all about vectors. So it's a mathematical concept which will enable you to sort of make things move and, you know, do a lot of different calculations that are required for kind of 3D graphics and 2D graphics and animation, all that kind of stuff. So it's a little bit of interesting maths, right? And we'll refactor our code. We'll do the bullet class without using vectors, and then towards the end we'll do the bullet class again. We'll refactor it to use vectors. And there's a couple of interesting little gotchas to do with how vectors work, particularly in processing, because it's based on Java. So there's some slightly counterintuitive ways that you have to do certain types of calculations and things. Okay, so just a quick reminder as well. I'm just going to put this up on the board because it's really important. I'll send an email later on today to everybody. The 13th of December is the date for our games design workshop, and I would love to have as many of you guys as possible at that workshop showing your work at about 12:30. That's on a Saturday, okay? So there's a few things just to say about that. Firstly, keep in mind that I'm going to be bringing at least 20 of you, or hopefully about 20 of you, to Games Flat. So that will involve a lot of organisation and hard work on my behalf, and this is your chance to say, thank you, Brian, for all the nice things you've done for us, and do something back for me, okay? Because I need loads of people there. The whole message of this workshop is that you can learn computer science by making computer games. That's kind of my theme for having this workshop. That's why I need you guys there, showing your games that you've written on that day. The other thing is, every weekend, because I'm teaching a course over at Angel Street on game programming for game designers, right? And every week I make probably one or two little games, and I made 2 more yesterday. And it just strikes me that every time I make one of these, I get better at programming. And I'm already all right at it. So it's the kind of thing you guys should be doing all the time, making little games or making little things in processing. And there's a million different things you could be making with them. And here's an idea. On the 6th of December, and again I'll send an email about this to remind you, on the 6th of December, there's an event called Gamecraft. And Gamecraft is a 12-hour games programming jam. So there's a theme given out in the morning time. Usually there's about 80 to 100 people do these Gamecraft events. They're really just amazingly good fun. I think this one's going to be held in Microsoft because we couldn't get the venue in DIT for that day because it's the open day in DIT, right? So you should register for it. It's about 10 quid to do this games jam. There's usually kind of fairly good prizes, but you basically just spend, I love it. I mean, you spend 12 hours basically coding, and then you've got a thing to show at the end of it. It'll be a great opportunity for you guys to do your next assignment. Your next assignment for me, I'll give out next Monday, okay? I just need a little bit of planning and working on the rubric and stuff. So there's a couple of events for you guys, right? The 6th of December is the 12-hour game jam. 13th of December will be an event for DIT where you just come in for an hour. Oh, the other thing about the event on the 13th of December, I meant to say, I'm going to reserve at least 20 places on that workshop for DIT students. Now, this guy that's doing this workshop, Ian Schreiber, is apparently one of the best game design lecturers in the world. He comes very highly recommended. He comes recommended to us from none other than John and Brenda Romero. John Romero, as you might know, is the founder of ID Software, who make Doom and Quake and all of those other games. Brenda Romero is an even more famous game designer. She's John Romero's wife. And they recommended Ian Schreiber, and apparently Ian Schreiber is amazing. So this one-day workshop, if you want to participate in it, of course, a game is just a complex system. And you get a load of, you know, the whole workshop is all going to be about making systems, making game systems, coming up with the rules, coming up with the variables. And that's what the workshops. And they're immensely fun. If you've never done a game design workshop before, the game design workshops are incredibly fun, very creative. Yeah?
Sorry, which one is that?
So the 6th of December is the game jam. So that's a 12-hour make a game jam, okay? If you do Google search for Gamecraft, you'll find the Gamecraft website, and you'll find where you register for that, okay? It's 10 quid to do the Gamecraft one-day game jam. And usually you get lunch and maybe a t-shirt and stuff like that as well. This event on the 13th of December will be held in Angel Street, DIT. If you want to just come and show your game, I need people there at about 12:30. But if you want to participate in the workshop with Ian Schreiber and do a team and all the crazy stuff that Ian Schreiber is going to do with systems design and games design and board games and all that crazy stuff that he does, and it really expand your mind and help you to think bigger about how to make systems and be creative, you can do that workshop as well. So that's an opportunity for you guys. All right, everybody. So I'll send an email about those two things, and I'd really love to see as many of you there as possible, right? Because really, that event, like I say, is all about, for me, the theme of it, why I've been doing it every year, is sort of get people into the idea that you can, if you're interested in making games, you can learn really good computer science by making games. And I'm sure you all realize that from doing your first assignment. Those of you that did it, you know, the stuff that you learned, you know, you hopefully learned about arrays and maybe classes and objects, and also just maybe had that nice feeling, that really pleasurable feeling that you get when things are going well and you put it together and you're being creative, and at the end of it you've got a thing to show. It's very exciting, isn't it? Oh, you all love programming. I just love it. My Sunday evenings are such joy. All I do is make games on Sunday evening and processing. I'm sure you do the same. Yeah.
When is our next assignment going to be due?
It will be due the week after we're back after Easter. So like the first week we have lectures. Sorry, after Christmas.
Okay.
Yeah, after Christmas.
So after the second part of the exams?
Yes, after the exams it will be due like maybe the last week in January, the first week in February, whatever week we're back.
Okay.
And I have a really cool assignment. The other thing I'm doing for the assignment is just to make sure that there's no ambiguity with regard to how the grading is going to be done for this assignment. I'll provide you guys with a rubric. So a rubric will tell you exactly what you need to include in your assignment to get a 70, to get a 60, to get a 50, to get a 40. And also the types of assignments that will get those particular grades. So you should be able to grade your own assignment when you submit it and come up with the same mark that I've come up with. All right? So that's called a rubric. I like to do them, but I didn't do one for the first assignment, but I'll certainly do one for the second assignment. Now, is that okay? But anyone want to ask any questions about those? Yeah.
No, it was just...
Okay. So. Alrighty. So if you guys remember last week, the sort of big, we had loads of learning stuff last week. Did anyone watch Daniel Schiffman's video that I put a link to on the website? Anyone watch it? Because I didn't make a video last week because the video turned out just the camera wasn't great. Did anyone watch it? So I put a link to it because I didn't make a video from the lecture last week. So I put a link to Daniel Schiffman's video. Daniel Schiffman is the guy that wrote the book, you know, the two processing books that I use. And he has a nice video about polymorphism, right? So if you want to watch it just to get a different perspective, you can watch his video. It's basically the same stuff that we did last week. So, yeah. So last week we refactored our Space Wars program, and we ended up with a base class called Game Object, didn't we? And what did we put in the Game Object base class? What fields did we put in?
X, Y, theta.
Cool. So we put X, Y, theta. Did we put any methods on the Game Object class?
Display.
We put a method on it called display,
And an empty move.
and another method on it called move. Cool. So then we made subclasses of Game Object. And if you remember what a subclass looks like, this is the way, if you're doing software engineering, this is what the diagram looks like to say a subclass of. So then we had two subclasses. What subclasses did we make? Did we make a player subclass, or did we call it ship?
Player.
Player. So we have a player subclass. So the player, what did the player add to Game Object? What extra things did we put in the player class?
W and H.
Oh yeah, for the width and the height, okay. Did we have any extra fields in there?
We had, what's the method of the same name as the class?
Oh, constructor.
Yes.
Okay, so we had a constructor called player.
Had about 3 of them.
Cool, we had overloaded constructors. So we had overloaded constructors, and what else did we add? We also had a display and a move method here, didn't we?
Yep.
Now, when we do this in code, what's the new keyword that we learned last week to do this kind of relationship between classes? Extends. So now we can say that a player extends the game object. And then we also made, didn't we do the star last week? And we did also the polygon. So we have star and polygon. So all of these extends. What did we add to star? Did we put radius in there? Pretty sure we had radius. And we have a variable to control the number of sides, or points I called it in star, didn't I? And in this one I had radius, and in this one we had sides for the polygon. And we also put some methods in here for display and move, and also had display and move here as well. Cool. So that's the diagram that we can draw to indicate the relationship between the classes. And we have this new keyword here called extends, which means that everything a game object has, a player also has, and everything the star has, everything a game object has, a star also gets all of that as well. And the same thing for polygon. So that's the keyword extends. Is that okay with everybody? So yeah, what do we call this? This is in terms of like just understanding the terminology. What's the relationship between player and game object? Of course, it extends. Yeah. So this is, you'll use different terminology depending on the language and depending on the book. We can say that player is a subclass. And what's game object then? Game object is the superclass. So guys, you should take these notes, right? So you know what these terms are. This is called a superclass. If you were writing C#, you'd have exactly the same concept, but you wouldn't use these terms. You would say that game object is, does anybody know what the term is in C#? Game object is known as the base class. And I think it's also called a subclass. Maybe it's the subclass and the base class. Subclass, base class. Yeah. So if you were doing C++, you'd have exactly the same concept, but particularly the older C++ books refer to this concept in a different way. They call this a generalization. And this is called a specialization. Okay, so that's the terminology. Is everyone kind of clear in that concept? So that was the first thing that we did last week. We looked at making subclasses, okay? And making subclasses, you can make these kind of relationships. And the big advantages with using this type of approach is that you end up with less duplication. So if you end up with a lot of code in here and a lot of code in here, and you find it's the same code, what you can do is refactor your project to take all that code out and put it into the base class, so that they all share the stuff from the base class. So a couple of other concepts then, right? Yeah, see the way I've got a display method and a move method in here, and I've got a display and a move method in here. What's that called? Does anybody know what it's called? When you have a method with the same name as something in the base class. Does anyone know what that's called? That is inheritance. Yeah, this whole concept is called inheritance, right? But this example here where the method is the same name.
Polymorphism, is it?
Not quite, no. Polymorphism is a slightly different thing, right? We'll get to that in a sec. This is called method
Mutation?
No. It's called method overloading. Okay, so this is overloading. Is it called method overloading or overriding? I think it's called overriding. Huh? I think it's overriding, not overloading. I think means having methods with different numbers of parameters to say method. This is called overriding. This is an example of method overriding. So you can say that the polygon overrides the display method in game object. Here's a quick question for you, and actually there's a few little sort of things that we didn't kind of discuss here. If player has a constructor and game object has a constructor, and you override the constructor, in other words, this has a default constructor, does the constructor here get called? Does anybody know?
No. The subclass method supersedes.
Okay. But what if you had, we'll say, variables up here that weren't getting initialized in the constructor here?
Well, then it should default to superclass, right?
So actually there's a rule here. We can try this out. And the rule is, unless you specify otherwise, when you call the player constructor, the default constructor or the constructor in game object that takes no parameters is also called. Why? Because when you're making a player, because the player is a game object, you have to also construct this thing as well. So by default in the player no arg constructor, and we'll actually see that, okay, this guy's no arg constructor gets called as well. If you want to call a different constructor, there's a couple of other little keywords that we can use. If I wanted to call a different base class constructor, does anybody know what keyword you use? Or I wanted to call something in the base class from one of these classes here. Anybody know what keyword I use? Super. Okay. So here's the first thing. In here you can go super. And what that will do is that will explicitly call the base class constructor. So if you wanted to call a different base class constructor other than the default one, you can explicitly call it using the keyword super. So you go super, and if there was a 2-parameter constructor, you could do the 2 parameters here. This, when you do this, this must be the first line of code inside the constructor here. You can also use the word super dot if you want to get access to things in the base class. For example, if you wanted to call the base class display method from the display method here, you could call super dot display. And that will call the base class one. So the last thing, that's all to do with inheritance. This thing here, this whole concept is called inheritance. When we have a base class, when we have these other classes that extend the base class, it's called inheritance. So the last thing that we did then was this concept of polymorphism. Polymorphism means many forms. And the example that we did on Friday was an example of polymorphism where I had a base class. Did I call my base class animal? Yeah. So I had a base class called animal, and I had 3 subclasses of animal. I had a subclass called dog, and a subclass called sheep, and another subclass called cat. So that's an example of inheritance. That's just plain old inheritance. The polymorphism example is when you keep references to the base class in something, and then you create them as instances of the subclass. So I'll show you the simplest example of polymorphism. By the way, I absolutely guarantee, 100%, this is going to be in every question on your exam, will be about polymorphism and inheritance. And absolutely every program that you write from here on in will have polymorphism and inheritance. Either on this course, when you go out to work next year, when you graduate, every program has polymorphism and inheritance. Even the simplest Android app that you write with like one form on the screen has polymorphism and inheritance in it. It is really just fundamental. It's like variables. Every piece of software has polymorphism and inheritance. So it's so important that you understand this and that you get really good at it. If you were to do something like this, animal A equals new dog. That's an example of polymorphism. That's it. Why? Because the type of A is an animal, but its instance is a dog. Does everybody see that? The type is animal, but the instance is a dog. And this is okay, because a dog is a type of an animal. It's okay to do this. The interesting thing comes if I had something here called bark. Right, say I had a method here called bark. Would I be able to go a.bark?
No.
How many people say yes? How many people say no? The answer is no. You can't go a.bark. The reason why you can't is because its type determines what methods you can call on it. Think about how the compiler is going to work, right? The compiler doesn't know. This could be inside an if statement. This could be, the user has to type some parameters and then, or maybe to type, do you want a cat or a dog or a sheep? So the compiler doesn't know that there's a bark method on A because its type is an animal. So this will not compile, okay? You can only call methods on the base class. But those methods, yeah?
If its type's an animal, why would you say it's a new dog?
Sure.
Like what's the benefit?
Oh,
You can't use bark.
Yeah, so the benefit is that we'll say you got a computer game, right? This is the perfect example, right? If you were in an interview and you're asked for an example of polymorphism and you give this example, then they'll think this is one that you just learned in the class, or this is one that your lecturer showed you, because it's one that all lecturers use, right? If you say, well, what if you had a computer game and you had a player object and you had a bullet object and they all needed to move and they all needed to update, That's probably a better real-world example of polymorphism. I'll show you. The big advantage with this is when you use it with something like an array list, because you can go array list, open angle bracket, close angle bracket, animal. Let's call this just list equals new array list, open angle brackets, animal, close angle brackets, open and close brackets. So what we've done here is made a list of the base class type. So this is a list of animal types. So that means you can put any subclass of animal into the list. It just means now that you don't have to keep track of any of the subclasses in 3 separate lists. You can just put them all into one list, and any element in this list could be either a dog or a cat or a sheep. When we're making our game, when we're making Yask, right, the Space Wars game that we're making, we will keep one list of everything that's in the scene, and then they can all be subclasses of the base class. So that's the advantage. It means that you have less code, you have less duplicated code. You don't have to go for each bullet in the scene, update and draw the bullets. For each player in the scene, update and draw the players. For each star in the scene, update and draw the players. You just keep one list of the base class, and then you just update everything. And it will call the appropriate method depending on what type of object is inserted at that point in the list. Does that answer your question? No? It's okay.
Sort of, but you can't use bark though.
Yeah. Sure. So what you do is you look at what do they have in common, and like for this example up here, they're all calling display and move, so there's no issue, right? Occasionally, if we need to do something like access a particular element and check to see is it a dog, is it a cat. In Java and in processing, you can use this, which is actually an operator. You can say if a instance of dog, and that will check the type of, sorry, that shouldn't be A, of course, that should be, because this is a list, it should be something like a.get element 0. So that's going to get the element at position 0 in the list, and check to see if it's an instance of a dog. And if it's an instance of a dog, you can do something like this. Dog D equals open bracket dog a dot get 0. So what's happening here is I'm taking it as an animal. First of all, you check to see if it's an instance of a dog. And if it's an instance of a dog, you cast it. This is an example of casting. You know, when you have brackets and you've got a type like this in open and close brackets, you can cast it to be a dog, and then you can call it d.bark. Like that. So that's polymorphism. That's polymorphism up there, the first thing. The second thing there, checking to see if it's what's its type, and if its type is a dog, then you can cast it to be a dog and call the method on the dog. So the cool thing here is, in this example here, if I keep a list of the base game object type, whenever I call display and update, it will call the appropriate display and update method on the subtype. So if it's a player, it calls the player display. If it's a star, it will call the star display. If it's a polygon, it calls the polygon display. Does everybody understand that? So it will look up the type of the object and call the appropriate method. And that's polymorphism in action. So that's an example where I have one small piece of code potentially calling one of 3 different methods. I don't have to call each of the 3 different methods explicitly. You just have call one method display, and it will call the appropriate one depending on the type of the object. Is that all right with everybody? So yeah, I think let's try an example of this. Let's finish off the little example we're working. How many people finished the example on Friday? Did anyone finish it? Okay, so everybody else, I'm going to put up the example on Friday, and if you guys can finish it now, you need some practice. You need to do this at least once yourself. I'll show you the little game I made, just because it is actually not a very good game. It's not one of my better ones, but it is based on Friday's lab. When I looked at Friday's class, Friday's tutorial, I thought, geez, you could make a game out of that pretty easily. No. screen's a bit too small, but should work, okay? Okay, this game is called Misty Slots. Who wants to play it? Yes. Oh, Keen, come on, you want to play. Yeah, come on, it's fine. There's actually not a lot of gameplay here, but it's still kind of cool. Actually, not that cool. Hang on a sec. So, yeah, you press I to insert coin. You start with 10 coins. So give yourself 20 coins, right? Yay! If you get 3 in a row, you get 5 coins. If you get a Misty, you get 10 coins, because Misty's the best dog in the world. So she's worth at least twice as much as anything else. I should change it so that the cat, you only get 3 coins or something. What's that? Don't press space and it just spin again.
Do you get a pick when it stops, or does it stop at itself?
It just stops.
Ah,
But you can't keep pressing, you just press space to spin. It's like a slot machine. So you just have to wait until it stops and then... Alright, there you go, you got another 5 coins. Press space again. If you keep going, eventually you might get Misty, huh?
I thought it was a weight thing, so you have to catch it.
No, it's just like a slot machine. Cool, that's good
Right.
feedback. Huh?
Is it rigged like real slot machines?
What's that?
Is it rigged like real slot
No,
machines?
it's not. It's completely random and it's completely equal. Quite exciting to play, I find. See if you get 3 Misties.
Have you got 3 Misties before?
Yes. Eventually you'll get 3 Misties just by random selection. You have to get 3 Misties. 3 cats.
Feels like you're winning a bit too much.
Well, there's just 3 pictures, so
Yeah.
yeah, probably needs a bit of game balance.
More cats.
Could be here for a while. One Misty.
What are they?
We're waiting for 3 Misties because I put a Misty set in. It's the most exciting thing in the game.
I can think out of it.
Oh!
It's a pause or you can catch those.
Sure, yeah. Or if you can bump, that'd be good as well.
That cat's face is just so mocking.
Come on, Keen, you're terrible at this game. I was getting them all the time yesterday.
They're bleeding chips now.
Yeah. We'll go down to 0, and then if we don't get one, we'll...
It's like real, that's it.
It's actually interesting. You win a lot at the beginning and now haven't won since.
But it's just completely random. There's nothing...
I'd like to pick how many times it beeps.
Random.
I mean, what?
I can't remember, I think it's like 5 and 10. And it does, I wanted to try and make it like slots, so the first one goes a random time, the second one is slightly longer, and the third one is slightly longer again.
You use a slash A like you can in C to make a beep.
I just used the minim thing in processing. I've recorded them.
Drops to 0.
Okay, Keen, that's it. Alright, no
See what happens
Misty.
if you try
So
it
what
again.
can we conclude from that? Misty clearly loves me more than she loves Keen. Because I got loads of Misties yesterday, huh? Taunting me.
Cats for the win.
Right, I'm gonna keep playing that game by myself for a little while. You guys know what you have to do. So the assets that you need are up on the GitHub, right? So you just need to download the image. You probably have these from Friday. Get the image for the dog, the image for the sheep, the image for the cat, and make 3 subclasses. Make some base class called animal. Make 3 subclasses, and yeah, you know what you have to do anyway. Okay. So press the space at random, and it's going to randomly shuffle them. When you press, you know the program. For those that weren't here last week, this was the program. Just till I show you. I might need to switch the branch. Oh, okay, I'm on the animals branch, so I should be able to just open that.
PyMage. It's a magician that uses Pi.
Where are you? Oh, the dog's cats. There it is. There. Yeah, so this is the program that you guys need to work on. For anyone that wasn't here last week, you need to make 3 subclasses of some base class called animals. You need to make an array list which holds those 3 and assigns them randomly depending on when I press the space. I want to get 3 random subclasses assigned to be the elements of that array list. And then when I press 0, you get the sound for the 0th one. When you press 1, you get the sound for whatever stored at 1. And when you press 2, you get the sound for whatever stored at 2. And just so that I know you all really want to hear Misty, so that's what Misty says. Okay, that's it. Get to work. Yes?